You just have to click. It's on loop.
No, it's not on loop. It's it'll end in 10 hours.
Oh, it's a 10 hours. Like it does loop properly. They just chose to cut off the loop spot.
All of these projects going through the autograder have 2 minutes before late penalty is applied.
Alright, I got mine in. Should I just stop on take a shit?
Oh, those six test cases are really heavy. They take a while. We got 1 minute. If it finishes after, late. You know why we don't take commit timestamps into account? Well, they're forgeable.
Well, the thing
but one thing we could do is we could say we could note when you have entered the queue and say, as long as you enter the queue by this time, you're in. But yeah, Ladies and gentlemen, your quiz will begin in 10 minutes. You'll have 20 minutes to finish. Please have Canvas open. Be ready for that quiz in 10 minutes.
Okay.
What's up? It's open now? Oh yeah, it's open now. Yeah. Yeah, you've got 20 minutes. The only thing I don't want is you talking to other people. Okay?
The biggest fix that I did was changing the hashtag.
Yeah, for me, I actually found that.
Speeds it up so much.
No, it doesn't. For me, the like 64 I'm using a custom hashing function I did. Yeah, there you go. Whereas I take the x, I multiply it by prime. I take the y, multiply it by prime. And so the two together.
Oh, it's like the same thing.
No, like I was thinking about like that one thing. Everything about my door. I found it at slow, and then I thought it takes time to do up. I just said.
Ladies and gentlemen, 5 minutes until the quiz begins. Please have the canvas open. The quiz is on canvas. You'll have 5 minutes to complete the quiz. You are welcome to use your notes and look back at your lectures. Please do not use each other's screens or talk. I've played it. I kind of bounced off of it.
I feel like some of the music would go really well.
Oh yeah? Yeah, I'll have to check it out.
Even so, I personally love the slap work, but I also just get the best. Between coding posture and your posture.
I had something like that when I was like debugging and stuff like that. Just trying to see what's the difference, what's the errors, it's small. Yeah, I can't see far enough.
Ladies and gentlemen, there are about 7 minutes left for most of you. A quick note, the question that asks for the 4 questions necessary in a build process appears to be messed up. So you'll all get points back for that one. I wouldn't burn any time on it, okay? Two minutes remain. Okay, ladies and gentlemen, let's get to it. If you are still doing the quiz, you can take that time and finish up if you want to. Otherwise, we'll get rolling. I think I said that quiz wasn't too easy. No, I think I said it wasn't too hard. Actually, the quiz is a little bit tough. I think this one was a bit tough. Do you agree? A little bit tough. I'm embarrassed. There was one question that I specifically worked on last night, and I ended up putting the wrong string, I think, into the Canvas UI, which made one of the correct answers, read completely wrong. So you're going to get those points back. I suspect that one was messed up by almost all of you, and so most of you will be getting at least 1 point back tonight. Okay? One of those things that comes with being a new course, a lot of little things like that slip by, and I apologize. So congratulations to all of you, though. You have completed homework 4, which is not a trivial assignment, okay? After that kind of warm-up with C++ of homework 3, things are going to start getting pretty real, okay? There's good news. You are soon going to start having homeworks that are going to be of 2 weeks in length, okay? And so, if you are looking for something of a break, the start of homework 6 is going to be maybe that for you, okay? You'll have a little bit of extra time on homework 6. You'll have 2 weeks. And then on homework 7, again, you'll have 2 weeks. Here's homework 6 right here. We are right here starting homework 5. Homework 6 will be 2 weeks. And homework 7 will have 3 weeks. It's designed for 2 weeks, so we hope that you will do no work over spring break. Just take that completely off to recharge. So there is some relief on the way if you're starting to feel that stress, that fatigue coming in, okay? But hold it together, stay strong, use your office hours, ask questions on Piazza and on Discord. If you didn't notice, Discord, the memes channel, okay, was getting taken over by discussion of the homeworks that I thought was beneficial and educational. And so I have given in and turned it into the official homework discussion channel. I guess there's a certain magic to that instantaneous feedback, right? That interactivity, the stuff you don't quite get on Piazza, okay? So you've got that going. So our mission today, our main mission is a pretty hefty one, okay? We might not get all the way through it. Our main mission today is going to be to introduce homework 5 and then to give you an introduction to SDL, okay? The simple direct media library. It is not so simple to integrate SDL, okay? But as it turns out, the big issue with the assignment, the reason it was so difficult, the reason the time estimates are so high in discussion and on the homework, is because last year's crop of students did not have any help integrating SDL. The guides weren't there. The video tutorials weren't there. The Windows one came in very late toward the end of last year's homework 5, and you're going to have all that from the get-go, okay? So this is going to be the easiest version of this homework that has ever existed, which I suppose isn't saying much, but yeah, it's going to be a good time. I think you'll really like this assignment. This is when your engine comes alive. You are writing C++ that opens windows, that renders to the screen, that updates over time, and I think you're really going to enjoy that, okay? Another reminder, if the quiz score is not what you hoped for, even with the additional point you're probably going to get tonight, remember your worst quiz grade is dropped, okay? And I think some of the upcoming ones actually aren't as hard. I think last year the students said, oh, this second one is pretty hard, Austin, so will you lighten up a bit? And I actually said yes. So I think the difficulty curve goes down a little bit on the future quizzes, so don't lose too much hope, okay? Okay, we've got an engine for you. We're going to go through this one pretty quickly since we've got a lot to do today. We have CryEngine. Have you ever heard of CryEngine? If you haven't, you might have heard of its second name, Lumberyard. Amazon basically purchased a license to it and released it under their own label, Lumberyard. And if you haven't heard of any of those two names, you might have heard of it as its third name, because Amazon open sourced the license and changed it into the Open3D engine. Okay? So a strange engine, CryEngine, used to be famous for the absolutely breathtaking visuals that it could produce. And it didn't necessarily do this on low-spec hardware. some engines, like the Ghost of Tsushima Sucker Punch engine, are famous for making just gorgeous aesthetics on very weak hardware, okay? Like the consoles, the game consoles. This engine was famous for breathtaking graphics, but it would make your computer explode, okay? The question that was famous around its era was, that might be a cool graphics card, but can it run Crysis? Okay? Crysis was Crytek, the company who made the engine. It was their big game. Okay? Crytek, the company in Germany, created CryEngine to run Crysis, the game. Okay? And that's how it went. Anyway, kind of a 2007 engine. It was notorious as a hardware benchmark. If your engine can run this, if your computer can run this engine, you're in good shape. Famously powerful with its visuals, it became very popular for people basically using it as a benchmark to test their rigs, their custom PCs, new consoles, GPUs, CPUs, stuff like that. But can it run Crysis? The game itself, and this is kind of anecdotal, but the game itself, beyond being beautiful, it was considered kind of a goodish, pretty good first-person shooter game, okay? Nothing super special in game design terms. This is not Half-Life 2, or Half-Life 1 even, okay? It was available to third parties, but it was never really as popular as Unreal or Renderware was. I would say it probably wasn't even as popular as the Source engine, Valve's engine. But it was still available, and on occasion teams used it. Now, famously, there was a game in the Sonic franchise, a game called Sonic Boom, that decided to use Crysis. They decided to use Crysis because of its gorgeous foliage and ability to do beautiful jungles. The Sonic Boom game was going to be set on kind of a jungle island, so it seemed like a reasonable fit for the setting and theme, okay? I want to point out really quickly, CryEngine's website right here, okay? It looks great, beautiful, wonderful. If you go down just a little bit, you find something really funny. On their breaking news, top of the homepage headline report, Spin Shot Party releases on Steam. This must be their biggest blockbuster of the week, okay? If they are, I'm sure this is a great game, but if the big game you're advertising for your engine, like runs CryEngine, is a foosball simulator, like, is that the only game that uses CryEngine releasing this month, this year? Okay, well, we got some asset packs at least, I guess. Anyway, I hope the engine is doing good because it's got a cool history. So Sonic Boom was a game that was being made by Sega, who was the publisher, in conjunction with a new studio called Big Red Button in, I believe, Los Angeles. Big Red Button was a former Naughty Dog squad. And so, pretty good talent, you hope. And the game apparently was coming along pretty well, until midway through development, Sega said, hey, this game you're working on, this Sonic game, is going to actually be a Nintendo Wii U exclusive. And CryEngine does not support the Wii U. So our dev team had been working, I believe, for years on a game on an engine that didn't support the target platform. Now, why did Sega do this? Well, Sega had a deal struck with Nintendo, right? They are historical rivals, but they're very much buddy-buddy in business. So they said, hey, we need 3 exclusive Nintendo Wii U games, and this is going to be one of them. It has to be. And unfortunately, they got wrecked, okay? There's a What Happened episode on the topic that goes into kind of what a disaster the production was. And it really was a disaster. I think what's Sonic Boom's Wii U... Okay, what's the Metascore here looking like? Okay. Oh, no. Okay. 32 out of 100, okay? And that's 28 critics. Not much better for the fans, okay? 757, okay? Absolutely brutal. This game was very, very poorly received. And a big part of it is that they had to... Yeah, there you go. Video game disasters. They had to work extra hard to get basically a weird port, a glitchy port of CryEngine working on the Wii U. A console it was never really meant for, it was never designed for. It didn't really have official support from Crytek to work on their Wii U. They had to spend most of their energy getting it to work. That left no resources for the actual game, okay? And it was a disaster, okay? They were shut down, I think. Are they shut down? Hold on. They were doing some VR stuff. They pivoted. We love making games. Yeah, they pivoted to VR stuff, and it looks like they are still going, okay? They even have Sonic Boom listed on their website. They are brave, okay? Good for them. Very good for them. Okay, anyway. So this is to say that it is very important, the choice of engine that you make, okay? And business and production and your technology, it all intersects, and making it all work together is important. If Big Red Button had a better relationship with Sega, or if they had been able to foresee, or if Sega warned them there's a decent chance this project might be pushed onto Wii U, it would have dramatically changed their choice of engine, wouldn't it? Okay, so you have to be very careful about these things, and business needs can sometimes really wreck you if you're not careful, okay? Okay, so homework 4, right? Homework 4, a interesting homework to kind of reflect on. A couple things. The performance tests that are kind of made homework 4 very difficult toward the end, they're not going to be there on homework 5. They will return for homework 6 and homework 7 and some of the other ones. But it is kind of the first big challenge of, how do I get my code running quickly? How do I achieve good performance? When you talk to the instructors and you go to office hours and you're asking, how can I speed things up? It's kind of a difficult question for us to answer. Why? Because you own your code base now. You are starting to customize it. You're doing a lot of little small things that we won't be able to know about unless we really look through the whole thing. There are algorithmic things, okay? So are you, being very careful to only deal with things when they're in the camera's view, right? And ignore them otherwise, right? That's a big thing that can save you a lot of time. But one of the best things you can do for getting your code to go faster is to profile it, okay? It all starts with the profiler. And you might say that theoretically, the vector should be faster than the map, okay? For some sort of container, or the linked list. But you really, really want to make an educated guess and then go in and profile it. Do some tests, do some experiments. You might be surprised what happens. I will tell you, when I was designing this game engine and the performance test cases, I was in there doing experiments, okay, on the staff solution, and I would think up a new optimization. Oh my gosh, amazing, amazing. Wait a second. One of them was I switched representation of colors away from an int to, I think, a short or something like that, okay? Because you only need 0 to 255 in this course for representing colors. So, oh my gosh, this is going to make our data structures smaller. That is going to improve the cache hit rate, and we're going to get a massive speed boost, right? Right? This makes sense, right? No. Boom. Loss of 20% performance. You know why? It was because the compiler, I believe, was struggling to apply the same optimizations to the short data type that it was to the int data type. I guess that makes some sense. Hardware, ints are so common, hardware is going to be very geared toward ints. But sometimes you have an optimization idea, you think it should work, it makes sense on paper, doesn't work, okay? And so you have to get used to that. That's how things are often in industry, in real life, okay? So please keep that in mind. Go to the profiler. If you don't know how to use the tools, maybe we can help you with those. Yeah, keep that in mind. Okay, another thing, if you didn't get all the points on this homework, remember this is a tough course, okay? Real tough. I would say it's a tougher course than 494. 494 at least is a capstone, so we grade a little bit more gently in that course. We have to get that average to a B plus, okay, tops. in this upper level CS, okay? This is going to be a tough course. And if you wonder why I have to do that, that's one of the policies upper level CS courses have to do. So don't feel bad if you're if you're missing a few test cases. That's actually really good, okay? I think the average is not super high on that homework 4. So if you're getting most of the test cases, you're rocking and rolling, okay? So do what you can to kind of keep your spirits up, okay? Once you get most of the test cases done, it is valid to say, you know what, I'm just not feeling it this week, okay? I'm going to optimize next week when I'm given 7 additional days of time, or 14, homework 6 and 7, and go and chill, okay? Remember, extra credit is on the way. There's going to be all those feedback forms. You're going to get that at the end. Remember, the exam is going to be designed to not be as hard as it normally would be, okay? In fact, I'd say the exam, general, can be a bit easier than this quiz you just took, okay? So we'll see. We'll see if I can nail that. I did last year. All the students were very happy with me last year. Hopefully you'll be happy with me this year, but we'll have to see. Anyway, don't let your spirits get down. Do what you can to keep up with the homeworks. You can always go back later. Question?
TV's about to turn off.
Oh, really? We taking that long? Okay, so I feel like it should be able to know that the signal and the displayed data is changing and be like, we should not turn off right now. I think most TVs do it that way. Anyway, okay. So blah, 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 blah. Your text adventure is now customizable, okay? It is not what many people would call a game engine, but you have a moddable text adventure game, okay? Soon, right, this week we will move into visuals, and then soon we will be able to customize logic, and that's really going to help things feel more like an engine, okay? Your first SDL assignment is releasing today. We'll talk about that in just a moment. The course isn't necessarily going to get easier. I would say it probably won't get a ton harder, but hopefully your work from here on out, especially if you're a very visual person, right? You enjoy the arts, you enjoy media, characters, charm, personality. The course is going to really start to have a lot of that, okay? So as we leave the world of ASCII. So let's go ahead and do that, all right? Let's get out of here, and let's get from ASCII to 2D. So this is the journey you are taking this week, okay? The gameplay is not changing, but the world, the aesthetics, the way we represent things is going to come to life, okay? We're going from the world of ASCII, right? Very kind of 80s, 90s, to the world of 2D. That's high-res 2D. It even has kind of a Flash-era art style, if I'm being serious. And so we're moving kind of from the 80s and 90s to like the early to mid 2000s in terms of the tech that we are using, okay? Last week, ASCII. This week, it's all going to be about getting SDL running, getting it doing the things we need to do, okay? Game designers, as many of us are, might not like it, but aesthetics really, 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 really matter. Okay. In fact, it's why Evan and I are dumping so much effort into the new EECS 298 course, the 3D Technical Art course, available now, because it really matters, right? You can make the world's best designed and engineered game under the hood. People aren't going to care if it's not stylish, if it doesn't look good, if it doesn't pop off the screen. Okay. So we have to figure that part out too. Aesthetics really, really matter. Okay. I want to show you a famous commercial. Are you ready? This one might hit the nostalgia bone for a few of you.
16-bit arcade graphics. 16-bit sports action.
Right, so in this commercial, you can hear them talking about 16-bit, right? You can hear them showing a lot of very fast footage, and you get this vibe that, right, the Genesis has things that the Super Nintendo does not. Now, was this true? Most people, historical scholars on this topic, say no. They say the Sega Genesis was actually a weaker console. It had less graphical and audio capability than the Super Nintendo, its rival, okay? But aesthetics and style really matter, and they really tried to sell that, and they did, okay? Here's another commercial that's very telling. Blast processing.
The Sega Genesis has blast processing. Super Nintendo doesn't. So what's blast processing do? And what if you don't have blast processing?
Okay, Sega has a lot of games during this era that are very fast. They're very in your face. They're very big. They're very colorful. Okay, Nintendo's entire vibe is more family oriented. It's a little bit more subtle, a little bit more nuanced. Okay, Mario doesn't have the tood that Sonic does. Okay, what is blast processing? Can anyone tell me? It's a marketing term. Okay, it is a marketing bullet point. There is, I think there's like one or two technical specs where the Genesis actually technically slightly has like a slightly faster CPU or something. But in practice, it doesn't matter very much. And games like Sonic could definitely be done on the Super Nintendo. But Sega harped on that, right? Because what aesthetics really, really, really matter. And so, for most of gaming history, the prettier game, the prettier console sells the most copies. Has this changed? I would say in some ways, maybe. But in others, not so much. You might look at a game like Undertale, okay? Right? $87 million in revenue. Incredible. Okay, a game that in many instances barely looks like anything made this much money and just dominated the market, except they didn't, okay? Because Call of Duty, the latest of Black Ops, okay, brings in $2.75 billion, all right? And so it still does really matter. You can make a good deal of revenue via a simple-looking game with very simple aesthetics, but you're going to be capped, okay? But this is a sign of a maturing industry. You don't need to fight for every pixel the way you used to, okay? You can make a simple game and still make a good living, all right? Anyone hear of the Blair Witch Project? A good example from film. This film was basically, right, kind of like a camcorder, super cheap camera filmed. They had a very, very kind of casual style, okay, very homemade style to the entire film. It makes sense in the film's plot. They brought in $248 million on a $60K budget. Absolutely incredible, okay? Absolutely incredible. So aesthetics really, really matter, okay? Question for all of you, which of these two games, they're the same game, which would you rather play, okay? Which one looks more interesting? A little bit more accessible, maybe, okay? Who has more interesting characters? These two characters on the right might not be more interesting. Their writing might be bad, okay? But you're going to make some assumptions, okay, about which game has put more effort into its presentation, and thus probably other parts too, okay? So it's nice to leave the ASCII mines, okay? There are a lot of great things made in it, but, we're going to leave the mines, okay? Reminder for all of you, though, 3D graphics is another course. Professor J.J. Park teaches a new 3D generative graphics course, which is going to take you through the underlying algorithms for how to do this kind of rendering. And if you really want to learn how to author content, then you'll want to take the EECS 298 course, okay? This course is not either of those two courses. SDL is not going to help us so much with that. It's very sad. If you want to do this, you need to use OpenGL, DirectX, Vulkan, or Metal. You need to use a bunch of different APIs based on what platform you're on, and that is beyond the scope of our course. It would be a bit of a nightmare to do so, okay? So, engine changes, all right, for 2D rendering. You are going from this to this. You can see it really is the same game. We're just changing the way that we present things, okay? Health is now represented by icons. Score is now, well, it's still text. It's up in the top left corner. That's still the same. The actual views of the actors, right? The actual views of the actors has changed, okay? You can see several things have changed. The perspective of the camera is different. Characters can be represented not in the center of their image, but at the bottom, for instance, okay? Pivot points are now a thing. You've got characters, humanoids, but you also have actors like tiles that can be stood on. As you saw in that beach game example, you can have actors that are gigantic, that serve as backgrounds, okay? So things are getting a little bit more interesting and a little bit more expressive. We can create actual environments, actual worlds this way, okay? Basically, no change to the dialogue. It's going to stack up, in a very similar way. Okay, controls are another change that you'll have to think about. Okay, during the ASCII era in this course, we have to enter a command in order to make time progress. That's no longer true. Okay. This time, it's real-time gameplay, and you can move about as fast as you can tap the arrow keys, okay? NPCs will now make an action. They will do their AI. They will take a turn every 60 frames, okay? So you'll see them, right? Walking around and doing stuff like that, okay? The narrative tools available to us have changed, okay? Big walls of text are out, and now images are in. Also, sound effects, okay? So images, text, and audio come together to allow you to create more interesting narratives. You can have endings, okay? And they're going to be both audio-based, and they're also going to have images, okay? And so you'll want to do that kind of stuff, all right? So where is our engine? Well, our starting point was this hard-coded adventure, right? We want to get to the super expressive 2D engine and even beyond it, into physics and then super high-performance stuff in Homework 9, particles and all that stuff. We've done mods to make our world more expressive and changeable, make it crazy, okay? We are now, this week, adding aesthetics, okay? And this is the thing that's really going to sell a bunch of copies for us. It's the thing that probably will get people, like friends of yours, excited if you show them footage. You show friends footage of this, you have to have really cool friends for them to like that, okay? But I think pretty much anyone would see 2D aesthetics, cartoony stuff, and be pretty into it, okay? And then on Homework 7, which again is my favorite homework by a mile, you're actually going to move into the realm. You're going to break out of this kind of 2D cell-based adventure game and into whatever genre you want, okay? So some tips that might be of use to you. Start early. Now, this has been a tip for the last 3. We mean it in particular this time. Or you can take your time and get wrecked, okay? This week, however, I actually feel like it's going to be slightly easier for you, especially because of all the help you now have to integrate the SDL, okay? How many of you watched the discussion footage? And you're like, oh, right, great, wonderful. I'm going to get to see SDL get integrated right before my eyes, and then it cuts off, right? How many of you were there in person? So if you were there in person, I think you got to see it, right? Hopefully it's committed to memory because that footage is gone now, all right? It got cut off. You can't review it. The good news, though, is that I recorded a bunch of footage for you for every platform talking about what you need to do. And that was a big pain. I was there like last night doing groundwork stuff. Anyway, you have no integration or performance tests this week, okay? Performance is still, it's still important, but we don't have any like pathological test cases trying to really pressure your engine this time. You're probably going to get full performance points within an attempt or 2 on almost all test cases, okay? The bad news is that those are all coming next week. Homework 6 last year was regarded as the hardest assignment in the entire course. So, but you got 2 weeks, right? What's the big deal? You'll be fine, I'm sure. Okay, could be a really fun assignment. Okay, aesthetics, I think for many people are just really fun. Audio, right? Visuals. The SDL library is actually a really great library. It's very impressive once you've got it working. And you also have another helper script that will help you out a bit as well. The SDL library is industry standard for a reason, okay? It's very powerful. It's very well understood. There's a lot of helper code and examples you can find online, good documentation. GPT, as a result, right? AI assistants, in my experience, they're very good at giving you examples, right, for various SDL APIs, okay? If you wonder if you can do something in SDL, a quick question, a specific question to GPT or Gemini or whatever, is gonna do you well, okay? Hey GPT, how to load a font in SDL? And you'll probably get several options, okay? So some quick tips for you, okay? Don't waste too much time. Ask your AI assistants. You can Google stuff. Go to office hours if you need it. Ask Piazza. Ask the discussion channel on the Discord server, okay? But when you get all this information, I don't care if you get it from GPT. I don't care if you get it from Google or a peer on the discussion channel. That exam is coming, okay? And you will need to know some of these APIs. You'll need to understand how they work, what their philosophy is, okay? And so please, when you get something, understand it, okay? Poke and prod it, and that will set you up really well for the exam, okay? Yeah, and come to office hours, okay? Make sure you do. Not too many people come to my office hours. The whole staff is sad. We're lonely. So please come to our office hours, and because you're paying for them, okay? And that's what we're here to do, help you out. So yeah, this year we have new SDL integration video demos. So on the assignment spec, you can actually find these 3 buttons right here. You're going to want to watch those for sure, okay? In fact, you can just click on it right here. I'll show you the assignment spec. Last night, I saw tons of people looking at the assignment spec, okay? That's a sign that people are either nervous about it or they're excited about it, and I can't tell the difference. But make sure you read through this, and right here is where we're going to want to watch these videos, okay? That should help you out a lot, I think. If you get going fast on this assignment, you're going to make it all the way through, okay? And I think you're really going to like it, okay? It'll explain to you how to use the helper file, and this is when the autograder and its feedback becomes much higher quality, okay? Because you're going to get video footage and frame diffs for every mistake, okay? At least you should, all right? Let me know if you're not, because then I'll have to go fix stuff. A quick question, who are all these characters, okay? These characters and these aesthetics you see, I hope you like them. They were done by professional artists, so definitely not me. And they were made for games that we were prototyping as a company, Arbor Interactive, a number of years ago, okay? And we're still using these characters. We think they're pretty cool. But we were making kind of tower defense style games like this, okay? It was kind of museum themed. We also had a beach themed one, okay? The characters themselves had a lot of frames. Okay, one is called Cuff on the right and Spot on the left. Yeah, we had a lot of really cool features. Overkill, cool menu stuff, great art everywhere, cutscenes, like roguelike modes, dialogue systems. The problem is the aesthetics were great, but I could never get the gameplay to a point where it was really shining, okay? It was mediocre. I now know how to fix it, but now I'm designing courses. I'll get back to it eventually. This is all to say gameplay is still king. Aesthetics are important, but gameplay matters most, okay? All right, so we've got about 30 minutes. I might go a little bit over on this, but I want to introduce to you the basic idea behind SDL, the basic philosophy, okay? SDL, it's a big deal, okay? When it comes to porting your engine, right, the more involved your software is, the more things it tries to do, the harder it becomes to port, okay? How has your porting experience been thus far? Has it been as hard as you imagined? Sometimes when you're going from, for instance, Windows or Mac to Linux, you just add a couple words to your makefile and it's already working, right? But sometimes you've got it working on Windows and Linux, but you want to get it working on Xcode, and what happens? Any manner of thing seems to happen, right?
I was going to say, for homework 3, it doesn't want to read what my compile sources are. What do you mean my compile sources aren't there?
Yeah, right? You can see the file, right? The file's right in there. Use the file. Why aren't you using it, right? Yes?
You lose 2 days of your life because you didn't close the Xcode project between adding the new files, and that was the whole problem.
Oh, so caching issues, right? Yeah, so Xcode basically, right? Build systems, okay? So in general, it hasn't been too bad yet to do portability, okay? C++ itself and all the compilers, even if they're a bit different between the platforms, it's largely standardized. As long as you're not wandering into some dark corners or undefined behavior, you're probably okay. I mean, that's one of the reasons that if you start failing test cases on one platform, but on the other platforms they pass, right? It could be some undefined behavior, okay? That's the part that's not going to be standardized. You know, command line input and output, how you deal with things, how you launch things is a little bit less so. The hardest part for you is probably getting the various build systems to work, navigating the UI of Visual Studio, coaxing Xcode out of whatever weird state it's currently in, okay? But I have a question for you. Do you know how to open a window on Windows? It's right in the name. Surely it's going to be easy, right? How many of you have actually written like Windows API Win32 API stuff. Why did you do this? What was the occasion?
Yeah, I was doing one other project like way back in
Yeah.
8th grade where I'm like, hey, I want to make this thing render.
Yeah. Okay. All right. Yes.
It was a tic-tac-toe game.
Okay. And what was the occasion for you?
I heard it was bad.
You heard it was bad? And that made you want to try it?
Yeah.
Wow. Okay. Great. This is the right course for you. Okay. So, how to open a window? All right. Well, on every platform, it's going to be shockingly different. This is non-standard. Okay. So, what do we have here? On Windows, here's your Hello Window application. Okay. Up here, you're basically configuring a class, a set of properties for the window. Okay. Do you understand what LPFN WindProc means? Any of you? Yeah? No? Oh, yeah. Well, that's going to be some reading for you. You're going to have to take some time to read up on what that means and what the implications are, what kind of choice you need to make. What about a LPSZ class name? Okay, yeah, you know all about that, right? Oh, no, you don't? Okay, and there's more where all that came from. Okay, so you create a class. You then register that class with the Windows operating system. Okay, can't forget to do that. If you forget to do that, you're going to lose a few hours. Okay. Then, once you've told Windows about that particular class, you need to then tell Windows to create a window with that class, okay? Class name, right? You can provide certain options, okay? Learn to program Windows. By the way, do you know what that capital L means? Okay. And I ask because I've actually forgotten it. What does that L mean? Does anyone know? Oh, crap. Okay. CPP big L next to string. We're not moving that fast with this. Okay, a wide string literal. Okay, ordinary, the type of a narrow char. Wide string literal is array of W char T. Wide character.
Yeah, a wide character is a
array
UTF
of wide
16.
character.
It's a 16-bit
Yeah.
char, whereas standard is 8.
Yep. Okay. So there you go. Right. Okay. So anyway, you have a lot of defaults you can specify related to size and position. You can specify other options, right? Is there going to be a parent window? Okay. What are the implications of having one versus not having one? Okay. You've got a handle. Okay. How are you going to use this? Okay. How are you going to do error checking? Eventually, you get to the very bottom, and you finally have a show window function, which takes a couple things and shows the window, makes it appear on screen. Okay. So there you go. This is nasty. All right, but if it's the only thing that you have to learn, it's not too bad. We could learn it, right? You know, give us some time, we could learn it. Yes?
Is that still C++?
Yes.
Yeah.
Actually,
What makes you doubt it?
Yeah, it's C++.
Yeah, what makes you doubt that it is...
It could be C,
Oh,
actually.
no, it makes
It's perfectly valid C.
Yeah.
And I know that the Win32 APIs
Yes.
are written in C first.
Okay, so everyone, look at all this code, and then you get sad, and you dream of a simple API. What do you care about usually when you're creating a window? I just want to say where it is and how big it is, okay? And then make the window show up, okay? That's all I really want, all right? Give it to me now. Oh, well. So this isn't too bad if you're only working on Windows, but the life of a portability developer, someone who would port stuff between different platforms, is that you have to know many different operating systems, and you have to keep track of them as they change. OS X has its own way of creating a window, and it has its own language for creating a window. You know what that is? It's called Objective-C, all right? Objective-C, and it is funky. Okay, if you have not seen this before, it's going to look real strange, all right? Just the way that functions are declared, okay? Right, you've got a dash, right? You have to put your return type into a little parentheses, okay? Very strange stuff. And you also have a lot of strange function calling conventions. So in this case, you have these square brackets you put on each end of a function, and that's how you kind of call it. I think this is technically not a function call. It's like a message pass, which is kind of a funky message call or a function call. Anyway, this is Objective-C, so you have to learn an entirely new language to make this work. Okay, you have a variable defined up here. It's called a property containing a window reference, so an NS window pointer. Okay, down here you have basically a class, app delegate, and this is a special class, kind of like in Unity. if you give this class certain functions, they will automatically be called by the operating system when the program launches, okay? So this represents the larger application. This function, application did finish launching, is kind of like your start function in Unity, okay? It's a lifecycle function that gets called automatically when your app launches, okay? Down here, we're instantiating an actual window instance with some configuration. So self.window, establishing this variable pointer to point to this window being created, okay? The function, I think, is called blah, 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 init with content direct. Yeah, and it's initializing some memory for a window with these parameters, okay? Down here, we're giving it further customization. So we're telling the window object to set title function, basic macOS window, and then we're making it prominent so it is viewed, okay? You got all that? All right, this is gonna be on the next quiz. Actually, no, it's not, okay? Don't worry about that, all right? So how are you feeling about this, okay? Not super bad once you have a feel for it and once you study it. The big problem is that there's so much to know. It's so different, okay, and it's always advancing. We really wish that we could just always call this. This is like the universal API for a normal human being who wants a basic window, okay? Why don't we have this? Where is it, okay? What about Linux? Oh, all right, Linux, okay? We are dealing with the X11 API, okay? And so up here, we have some data types, some variables for storing the window reference, display stuff, some events, okay? We have to connect to a server, which might be confusing to you. There's this X11 server program that basically kind of manages and makes the windowing system work. It's kind of a strange name, but you get used to it, right? Down here, okay, assuming that the display opened up, by the way, what is a display? Do you know what a display is? Because we're about to worry about getting a screen for a display, okay? Are these terms confusing to you at all? Maybe they sound like synonyms, maybe, okay? It makes sense if you're used to all of this, right? A display is kind of a set of screens and monitors, sort of, all right? Once we have our little display, we can feed this display in to create a simple window, okay? That gets put into a window reference, and we can provide some, various parameters in that function call. Yeah, and then we get to display it right here, XMAP window, okay? There's just a lot of messy things in all of this that it makes it difficult to learn. It makes it difficult to understand. It's very unpleasant. That's what this whole tangent is about, okay? When we really just want this niceness over here on the left, okay? We want something really, really nice. One thing to note is that X11 is one of many different windowing systems for Linux, okay? Different distros might use different approaches, and so you have to learn them all and keep up to date with them as they evolve and change, okay? What a disaster, okay? If you can do all this, you can pay some big bucks, all right? You can start your own studio and you can port EA games or stuff like that. But remember, okay, that was just opening a window because you need to do this all again for inputs, which every operating system will have a different API for, a slightly different approach for, okay? Rendering. We didn't do any rendering, we just opened up a window. That's all we did, okay? What about audio? All right? What a mess, okay? They all change over time, all of this stuff. So, just press the button right now, okay? And get it over with. Is there no hope? All right? Is there no hope? We really need a simple direct API layer for multimedia. That's what we need. And so turn to SDL, okay? The simple direct media layer. It was a 1998 creation, so it's been around for quite a while. It was made by famous Blizzard developer Sam Latinga. In 1998, Sam was a porting developer. I don't think he worked at Blizzard at that time. And his challenge that he faced was that, oh my goodness, this is such a mess, right? All of these different OS operating systems have different APIs for all these different things. He wants a way to make porting games much faster, okay? And so the insight is that all of these APIs are weird and different, right? But they're kind of sort of all doing the same thing, right? Linux has a concept of a window. Mac has a concept of a window, and so does Windows, right? Okay, so it should be possible to create a unified, simple kind of standard API that can just make everything happen, okay? Thus, we only learn SDL, and we don't have to learn all these proprietary individual OS APIs, okay? Managing windows, rendering to set windows, playing audio, detecting user inputs. These are universal concepts that all of the platforms handle a bit differently, okay? And so this became reality, okay? This used to be just a dream, and then Sam showed up, and now it is our reality, okay? And we are happy. When I was reviewing the slides and I saw this image I chose for the Happy Cat, I was like, oh, that's like a DALL-E 2 image, I think. That's an old one, okay? And oh yes, there we go. So we're super happy now. So what is middleware? Well, before we had a situation like this. We had our gameplay code, which is what we really care about, on top of our engine code. The gameplay code calls our engine code, and the engine code that we're writing has to call into the Windows API, but it also needs to call into the OS X API and the X11 API and iOS and Android and WebGL and whatever you want, right? What a mess. We write all of this. It's awful. After SDL, what we have is this. Gameplay code calls into our engine code, but the engine code calls into an SDL layer. The SDL layer is what then calls into the operating system APIs for whatever platform we happen to be on, okay? And the key here, is that over here we have to write everything, okay? Blah. We have to even know how to call the APIs. And over here, we don't care, okay? Compare the number of arrows over here to the number of arrows over here. We just need to write the calls into SDL, and then Sam and his team, blood, sweat, and tears, they figure out the rest for us, okay? This is called middleware. It goes in the middle and saves us a ton of work, okay? And yes, pour one out for the SDL dev team. Their lives are basically studying these operating systems, which are constantly breaking things and evolving and introducing bugs and trying to protect us from it. Yes?
Who pays the SDL devs to keep doing this?
Who pays the SDL devs? Anyone? Are any of you people paying? Any of you on their Patreon? Okay, if not, why not? Okay. All right, so I'm pretty sure SDL is an open source project, and it's definitely open source. I believe they're getting funding from some of the big kind of Linux Foundation stuff. There are some groups that will fund projects like this to keep a handful of devs paid and alive while they do this thing. Sometimes open source devs have a Patreon, or they have a coffee or stuff like that to get funding. But a lot of these open source projects, they're just run by really passionate people who want to let people stand on their shoulders. Okay, it's really, really amazing stuff. But that's the situation. So something to remember, though, is that Sam built this open source project, uses it to do porting of games. So he makes money that way, and he just happened to put it out there for others to use as well, right? So sometimes that's how it goes, too. You'll have a company doing one business model, they'll open source some of their tools, and then it gets really big, okay? Oh, by the way, if you are Sam Latinga, SDL kind of makes you pretty famous, all right? Like if someone needs a port, okay, or if someone wants to hire someone who's really good at operating system APIs, like you know who to talk to. So sometimes you put open source stuff out there to build your own personal reputation and credibility, and that can turn to very real, tangible funding and payments down the line, okay, if you want it to. Anyway, SDL is very popular, okay? Factorio, anyone play it? Okay, very big game. Streets of Rage 4, action beat-em-up game. I love that game. Amnesia, The Dark Descent. Okay, that is a custom in-house engine that the Frictional Games team built themselves, and it sits atop SDL. Yeah?
I thought SDL was 2D, wasn't it?
SDL handles a lot of things. So this is a good question. So, right, Braid is written with SDL. Okay, Half-Life 2 is written with SDL. Did you know that Steam requires SDL? If you have Steam on your computer, you've got SDL. You know what it uses it for?
The workshop itself, or like the Steam.
I think for the Steam program itself, right?
I think the last I heard, the only thing Steam uses SDL for is opening up a window and input. That's it. Like that's it. It doesn't use any of its rendering capabilities, okay? So we've got a 3D game here. Thank you for pointing that out, right? You can use SDL for input, for audio, okay, for opening up the window, okay, for processing events. And then you can say, hey, we're going to just dip into the OpenGL library to actually handle the rendering, okay? You can do that. In the latest version of SDL, it actually does have a simple 3D API, but usually it's just not detailed enough to handle everything you want. Really quick?
Yeah, then I guess backing off of it, or bouncing off of that, so
Yeah.
then would like OpenGL devs and SDL devs need to work together so they can like both work in the
Oh, yeah.
same window?
Yeah, almost certainly.
Okay.
Yeah. Okay, some use of it for rendering, right? Some for input, some just for window opening, okay? But how do we use it? That's the most relevant part to your homework. And I want to get through this part real quick because it's going to help you get rocking and rolling on homework 5. We might go a bit over so I can get this to you. I want you to see homework 5 assignment spec because that has the biggest details. It really is going to help you do everything you need. But this is Hello SDL, okay? Gaze upon it, glorious, okay? This is what you're going to do. You only have one file you really need to include, and that's going to be sdl2/sdl.h, all right? And you're going to include that, okay? And you'll be able to build, but you need to make sure that you are linking, otherwise you're going to get undefined references and you won't finish your build, okay? What's going to happen here is you're going to have an int main function, and it's got to look like this. How many of you create int main, open parenthesis, close parenthesis? That's it. No parameters. If you do that, I think on Windows, your build will fail, okay? And you need to have exactly this signature, and then that basically gets kind of replaced. There's some magic that happens under the hood with the SDL library to make it all work. But what's going to happen is we enter main, we call hello SDL. We come in here and we do SDL init. This is an important function, okay? It kind of gets SDL ready to go, okay? Note that it doesn't give you any object. Like, you'd think like I'm going to call SDL init and that would give me an SDL class instance, and then I can call functions on it, I can mess with it, right? But that's not the case, okay? You'll notice something about SDL that might be a bit weird to a lot of you. Okay, so we call SDL, we want to init video, okay, so we can render things to the screen. We're going to go and we're going to create a window. This SDL_create window function does that for us. It takes a bunch of parameters. It takes position, where where do we want the window? It takes the size of the window. It takes some flags that change and turn certain things on or off for the window. Then we can give it a title bar, right? It creates the window, it creates a handle to the window, and we put that into SDL window star window, okay? And there we go, we now have our window, right? So now we can enter an infinite loop, and to prevent that infinite loop from freezing everything, we call SDL delay 1 to chillax for 1 millisecond, okay? And that is our hello SDL, okay? When we run all of this, right, when we run all of this, we're gonna get this window right here. Okay, it's going to pop up unless you're on Mac. Okay, on Mac, this won't work. You won't see it pop up. There will be a window, but it won't be visible yet, okay? I'll tell you why in just a sec. There's no error checking in here right now, so we add it, okay? Look up here. This SDL init function can fail, and if it does, it will return a value less than 0, okay? This is a very old style of programming. Okay, it is kind of a C style of programming where you'll often see functions wrapped in an if statement, and then inside of the if statement you see basically what happens to handle an error. Okay, so we've added this up here, we've added this over here. When we go to create a window, this will remain a null pointer if we fail to do so. So we check if the window is a null pointer, we do some error stuff on the way out. Okay, so we have a window, but we want to do something, okay? Let's find some cool drawing functions so that we can draw to the window, right? The SDL window type probably has some, okay? So when you start typing window and you put that pointer there, you expect to find a bunch of functions or something, right? But that's not what happens. when you type this, the auto-completion fails. Why does it fail? Well, it fails because SDL is a C library. It is not a C++ library, okay? C++, object-oriented, okay? When SDL was coming about, that wasn't as dominant as it was, right? Things didn't have to be OOP. So what we have here is a pointer to a window object, but this object, this window handler, doesn't itself have any data on it. It doesn't itself have any functions on it. So this is not how you're to call things, okay? When we get to box 2D, we'll call things in a more OOP, more modern style. It's much more familiar to you. But right now, we're in the world of C. We're in the 90s, okay? And so that's what I call C-style programming, okay? And so C was not very object-oriented. Data and functions tend to be kept very separate, okay? So autocomplete is going to work a bit worse for you. How do we figure out which functions are available to us? Well, we need to understand a naming convention, okay? And this sounds like something that should be on an exam or a quiz. The naming conventions for SDL. C-style, this is just how it tended to go, okay? What you would do in C-style situations is you write the name of your library, okay? You then write a topic. So I care about rendering, okay? And then you write an operation. And as you draw these things in, you'll get more and more refined in your code completion, okay? You can actually then start scrolling through like you normally would to see what is there, okay? So you can break it down like this. SDL underscore topic operation. And topic is about all you'll need to get to before you can start looking through things and finding useful stuff, okay? Or faster, probably, ask your favorite AI assistant, okay? And if they troll you, they literally just trolled me like an hour ago, okay, with Unreal Engine stuff. But you can ask them. They will give you some hints as to what's available, okay? So we find a function, SDL render draw point, okay? It takes a renderer handle and then an X and a Y. Where do you want to draw the point, okay? It returns an integer, which will be a -1 if it is a error, okay? I think my mic just died. Okay, we'll go through this really quickly, all right? A -1, when we make this call, we're going to create a render. We provide the window. The render is basically our tool for rendering into a window. So we give it the window we want to render into. We give it a -1, basically just grab the first like GPU driver that you find, and then and then 0, no special properties or flags, okay? So just a normal render, nothing special. What's going to see? What are we going to see when we do this? Yay! Nothing, actually. We see nothing. I was hoping to see a point, okay? We are rendering a point down here. You see, we're rendering a point in the middle of our window, 320, 240. Where's the point, okay? It's nowhere. So what's the issue? Well, it's time to talk about a famous topic in rendering. It's called double buffering, okay? This is a famous technique that tries to prevent something called screen tearing. In this video right here, you're going to see an example of it. It gets pretty bad, okay? Look very closely at these lines, okay? You're going to see them kind of glitch, right? Things look like they tear. The problem here is that we are trying to render something in the middle of rendering something else, okay? In the middle of a screen refresh, we are rendering an image, thus half the screen is the previous image and half the screen is the next image we want to render. And so that's screen tearing. Double buffering is a technique that prevents this, okay? We have two buffers here that we draw things into, okay? The active buffer is the one being shown on the screen. It's currently nothing, thus on the monitor we see nothing, okay? When we do functions like set our draw color and then render a point, okay? The inactive buffer, the one not being shown, is the one that we draw to, okay? As soon as we call SDL render present, sometimes called a flip, okay? Suddenly the pointer goes to the other buffer and now it's showing the things that we drew, okay? Now when we draw things, we will draw up here, and when we do another flip, we'll show the other buffer, okay? So further drawing happens up here. The image, for instance, is on the inactive buffer. We do a flip, and now we are rendering the other buffer, okay? So the takeaway here is that you always need to do a bunch of rendering, and then at the end of the frame, to finish the frame, you do STL, render, present, and boom, it shows up on the screen, okay? And there you go. And it just goes back and forth every frame, okay? So, rendering, right? We now have introduced this function call, and now, look at that. Do you see it? You see it? No? You see it now? Mission complete. Okay, mission complete. All right. Now, I think the last thing we're going to do today, and then we'll finish this up the next time, is how do we make it move?
You draw the point at another location on the inactive.
Yeah. Every frame, we're going to draw a point at a different position. I love it, okay? Let's do that, all right? So we've added some code. I now have a variable called position x, okay? And it's going to start at 320 halfway through, but every frame of our while loop here, we're going to advance that position x variable by 1. It's going to grow, okay? We're using that position x variable right here to decide where to draw our pixel. So now we're going to have a moving pixel, right? It's like, what? What's the problem here? What's the problem? We've got a line, okay? Why do we have a line? We don't want that. We want a pixel to move, okay?
Without clearing the screen between renders.
We are not clearing correctly, okay? So we need to clear. The problem here is that as our dot moves, we aren't really clearing or resetting our big render canvas here, okay? And so a dot moving over time becomes a line if you don't clean up where it used to be. And so we've made one final change here, okay? Not a huge change. We are setting our render draw color to 000, so black, okay, in full alpha. And then we are doing STL render clear. Every frame begins with STL render clear, every rendering of a frame. And at the end, we get STL render present to show it to the user, okay? And that's how we go. We are clearing with black color. Thus, do you see it? Have to kind of squint. Let me help you out. Victory, okay? And I think that is enough to get you started. I don't want to take too much more time. We'll finish up talking about STL in addition to some other stuff on Wednesday, okay? So thank you for letting me go a little bit over. And tonight you're going to get that point back probably on the quiz. Otherwise, if you're working on homework 4 or you want me to help you, you want to get linked right now. If you got linked tonight with the Hello World on a platform, the Hello STL, that would be a real good start, I'll tell you, okay? Real good. Okay, everyone, I will see you next time. Take care, and see you Wednesday. What's up?
I just had some questions about the direction of where this project goes with the custom features specifically.
Okay. Yeah, go for it.
I guess like two things I was wondering about is can that feature lead to like specializing the engine to a specific type of game, or just
sure? I mean, we're very, very flexible with the custom feature. That's kind of like your time to do whatever you want, so long as the scope is big enough, right? The scope doesn't need to be that big, but if you're just integrating DDR dance pad support, that's actually just a handful of lines of code changed in STL. Then you have to get the DDR dance pad tested and stuff. Make it maybe a little game, mini game, right? Okay, everyone watching online, thank you for joining us. I didn't forget about you, and we will see you later. Bye-bye.